I wonder how we will ride in our expensive cars, ride bikes, and travel in planes or trains when there are no more fossil fuels. Are we going to use water as an alternative to fuel? I'm pretty sure you know why I'm saying so. Yes, our days are numbered with fossil fuels. Hi, I'm Annussciah from NGIP UTM Kuala Lumpur. Today I'm going to present my research on non-catalytic production of biodiesel fuel from free fatty acid fraction of palm oil. The modernization in the lifestyle and the rapid growth of population have been resulting in the increase in consumption of energy. As you can see in the figure on the left, crude oil, which is a fossil fuel, is the second highest primary energy source in Malaysia, and as shown in the right, the transportation is one of the most energy intensive sectors, mainly depending on petroleum products. Globally, the transportation sector is a major energy consumer and source of carbon dioxide emission. The world energy demand continues to increase. The growth will affect the stability of ecosystems and global climate as well as global oil reserves. Malaysia signed the United Nations Paris Climate Agreement in 2016 to reduce the greenhouse gases by as much as 45% by 2030, which is in line to achieve the Sustainable Development Goals number 7, 12, and 13. One of the alternative ways to meet this growing demand is by utilizing alternative fuels to petrodiesel, which is heavily used in transportation sector. Use of biodiesel fuel is one way to reduce both the consumption of crude oil and environmental loading by greenhouse gases. Biodiesel fuel can be derived from renewable resources such as edible or non-edible vegetable oil, but it has been mainly produced from edible oils such as palm oil, soybean oil, and sunflower oil. The extensive use of edible oils for the production of biodiesel fuel could lead to so-called food fuel competition and its high cost. Therefore, one of the solutions to overcome these issues is to utilize low-cost feedstocks such as non-edible oils or waste cooking oils for the production of biodiesel fuel. Inedible fractions of crude vegetable oils such as palm fatty acid distillate fraction (PFAD) of crude palm oil can be used to produce biodiesel fuel. PFAD is produced as a byproduct in refining crude palm oil to cooking oil. PFAD contains high amount of free fatty acids in up to 80%. Also, it is low cost since it is a low value added byproduct. The conventional method to produce biodiesel fuel from PFAD is through an esterification and trans-esterification process. This conventional technology is carried out under mild reaction conditions such as reaction temperature of 60 degrees Celsius and can yield FAME, which is a BDF, at relatively low cost by using methanol and catalysts. However, there are some drawbacks in the conventional process, such as type of catalyst for acidic fraction is not the same for lipids fraction, so this requires more extensive separation processes and wastewater generation. Non-catalytic production of FAME from PFAD under subcritical water conditions is a potential solution to overcome the existing problems. The saturated hot water in subcritical condition has a very high ionic product and also low dielectric constant, which is why water behaves like an organic solvent and more reactive. No catalysts and chemicals are used. The water itself plays the role of catalyst and solvent in subcritical water conditions. Subcritical water method is very efficient for any refined oil as well as oil with high free fatty acid and water contents, which is a suitable non-catalytic method to produce film from PFAD. These are the objectives of my proposed research, which are characterization, subcritical water treatment, and elucidation of biodiesel fuel production and treatment conditions. By achieving these objectives, I believe I can prove the new non-catalytic biodiesel fuel production is possible. Thank you very much for watching my presentation.